Good morning, everyone. Today I'm presenting on Project Insider Threat Detection and Behavior Risk Analysis System. This dashboard is designed to detect suspicious employee behavior using data science and interactive analysis. So, firstly, this tells us how many rows are there in our data. There were 1,17,583 rows in our data, and columns were 120 columns, which are the features of employees, which is strongly linking to maliciousness or not. Then the overall malicious rate of our dataset was 5.12%. There are two tabs, View Dataset and Open Power BI. When we click on View Dataset, this is a dataset preview. We have only selected 12 sample rows for just presentation. And when we have to see any one feature from the dataset, we have to apply the selection. And it tells us that how many employees have this feature at 0 or 1. We can reset filter again. And this is our previous data set. After clicking on clean data, we can see what cleaning process were applied to our data set. We have removed 354 duplicate values and make it to 0. We have normalized data types. And we have also applied engineer derived features. This is our clean data set. Let's move towards EDA. In EDA, we have four tabs: univariate, bivariate, multivariate, and insight. In univariate, we have compared frequency and total activity. Frequency means total number of employees. Here, this graph is showing a large amount of employees have total activity very high, and very less count of employees are there which have total activity that is different activities which are not belong to office. The number of employees have it is very less. In bivariate analysis, we have compared moment anomaly and off hours ratio. And this blue dot it is telling normal employees, and orange dot is telling malicious user. And these are the values of our ratio, moment anomaly, and class is normal. Here, very less number of employees have off hours ratio high and moment anomaly low. In multivariate analysis, we compare multiple features, which shows if the what features are strongly linking for the maliciousness of any employee. That is, for example, is malicious is a feature, total file burns is a feature, and the correlation between them is 0.361 value, which is telling us they have some connection so that the employee will be malicious. And the strong connection is 1. Total file burn and total file burn have strong relation, so that it will tell us that this employee is malicious. In insights, these are the main features which are strongly related to the maliciousness of employee behavior. Total file burn have the most correlated signal, which is 0.3610 value. Let's now move towards hypothesis testing. So, user works outside of normal hours between normal and malicious users. The t statistic is negative 9.13, which is extremely large in magnitude. The p value is essentially 0. This means malicious users operate significantly more during off hours than normal users. And this difference is not random chance. The outliers are 12,667. The IQR bound collapsed from zero point 0.0 to zero point 0.0. This means most users have zero off hours activity. So in conclusion, we reject the null hypothesis. Off hours ratio is a strong, statistically confirmed signal of insider threat. In chi-test, in chi-square test, This checks whether the late exit flag, whether a user stays late regularly, that is, whether it is related to maliciousness or not. The chi-square is 0.0. The p-value is the p-value is 1.0. This is complete opposite extreme. This is zero statistical association between staying late and being a threat. Both normal and malicious users stay late for different reasons. So in conclusion, fail to reject the null hypothesis. Late exit flag is not a user useful predictor. So now the ANOVA testing. We compare total files burned across three risk tiers: low, medium, and high. The F statistic is 74,444. It is extraordinarily high. The p-value is again 0. Looking at the box plot, the low risk group almost 0 files on average. Medium is around 85 to 95. And high are completely separated. We found 22,475 outliers. Users in the low group who still burn 35 to 45 files. These edge cases are exactly what our system is designed to catch. In conclusion, we reject the null hypothesis. Files burn scales directly with threat level and is one of our most powerful detection features. This is all about hypothesis testing. This is a Power BI dashboard. Is analyzing employee or user risk levels based on behavioral data. In the top left, we see a KPI card showing an average threat score of 3.61. This is the key risk metric being tracked. The scatter plot in the center plots the average threat score against off-hours activity ratio. The blue dot represents the high risk group, sitting around the threat score of 3.5 and an off-hours ratio of 0.07, meaning high risk users tend to be more active outside business hours. The bar chart in the bottom left shows this one, the average threat score broken down by risk level, currently filtered to show only high category, confirming that high risk users have an elevated threat score near 3.6. The slicer in the center lets user filter by risk level, high, low, or medium, to compare behavior across groups. On the right panel, we can see this is built on feature engineered dataset with risk level as the core visual dimension. This dashboard is security or HR monitoring tool designed to identify high risk individual based on what they were and how active they are.
This section allows users to input key behavioral features such as total activity, off hours ratio, burn ratio, moment anomaly, and activity per entry. So, based on these inputs, the model predicts whether the behavior is normal or malicious. So, I have already given some inputs. Now, let's see if it predicts or not. So it predicts that the output is malicious, indicating the suspicious activity. Next is the model metrics to evaluate the performance of the prediction model. So the model used here is the random forest, and the accuracy is 97.6%, precision is 88.5%, recall is 60.7%, F1 score is 72%. Then comes the confusion matrix. This confusion matrix visualizes the model's performance. It shows how many predictions were correct and where misclassification occurred between normal and malicious categories. These are some of the counts, and they are highlighted with different colors. So then comes the time forecasting section. So this section analyzes trends and predictions future values using moving average and ARIMA models. So there are 16 total data points. As we can see, the series points here are 16. Then the 13 are used for the training and 3 are used for testing. And the moving average window size is 3. So the trend graph. This graph shows the trend of total activity over time. So we can observe the fluctuations here and spikes, which help us understand the overall behavior before applying forecasting models. So the forecast comparison, uh, yeah. So the blue line represents the actual data, red line represents the moving average forecast, and the green line represents the ARIMA forecast. So this helps us visually understand which model is closer to the real values. So the error matrix. So we have displayed some error matrix here. So to evaluate forecasting performance, the moving average has MAE of 1.32 and RMSE of 1.66. The ARIMA has MAE of 2.02 and RMSE of 2.27. So in this case, the moving average performs better than the ARIMA. So overall, this is the website we have created or the platform we have created where we can show the data set, EDA, and hypothesis prediction and the time forecasting all together. Thank you.